Today's math strategy video is on understanding volume. So volume measures the 3D space that's inside of an object. So like think about like a swimming pool, like the water, what's inside of it. Your parents' gas tank that's in their car, the volume is how that's measured, the liquid that's inside. Also think about a washing machine in your house, like what's inside of the washing machine, like that is measured by volume. So what we're going to do is we're going to talk about comparing area and volume. So you've already learned about area. So now we're going to take what we know about that and we're going to kind of transfer that to volume. So when I think about area, I'm thinking about just a unit square. So thinking about the, like carpeting something. So, or like tiling something, maybe in your house. So it's like a flat surface. So it's the area. So this would just be unit square. And then this would be 4 square units here. Now, when we think about volume, we're thinking about a 3D shape. So something that's not flat, and it would be unit cubed. So if I look at this would be 4 cubic units because it's 3D. It's not just a flat object. So some of the characteristics of area here. So it would be a 2D shape versus volume would be a 3D shape. So that means that this would be, flat. And this would be a solid. You measure area by, so we talk about the length and then the width of it. So length times width. So this would be 2 by 2 to get 4. Whereas volume, we're looking at the length, the width, and then the height. We have an extra measurement here. So we're also measuring a flat surface. So measures flat surface. And then this measures inside an object. And the measurement that we use, let's say if we had inches, it would be inches squared. And then this would be inches cubed because it's cubed because we're looking at a 3D shape, whereas this one is a flat shape. So let's look at an example problem. Okay, here we have our problem. It says, Leah built this rectangular prism with unit cubes. Then she took apart the prism and built a different prism with the same number of cubes. Draw a picture of the second prism that Leah could have made. And then describe the number of layers and the number of cubes in each layer of both prisms. Okay, so we're going to look at this prism right here, and it looks like, so we have a height, so, or it doesn't matter which one. If you were to call this, width, height, it doesn't matter, as long as you have 3 measurements. So this right here would be 2, because I can count, 1, 2, and then I'm going to count the length down here, 1, 2, 3, 4, 5. And then I also have this width right here. This is 1, 2, so that would be 2. So I have a 2 by 5 by 2. So a 2 by 5 by 2 would be 10 times 2. That is 20 cubic units. Now, I can also count these. I have 1, 2, so this, I'm going to count this top layer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 on this top layer. So if there's 10 on this top layer and it looks the same on the bottom, there also has to be 10 on the bottom. So 10 there and then 10 on the bottom. That gives me 20 cubic units. Okay, so what it wants us to do with, I've got 20 cubic units. And we want to draw a different prism. Okay, so I'm going to do my very best drawing that I can with this pad. Okay, so what I'm going to think about is I need to have 20 cubes, but I want to arrange them differently than this. I can't arrange them like this again. So what I'm going to do is I'm going to arrange them in layers. Let's say I'm going to have 4 layers. All right, 4 layers. I need to probably just erase this right here. I know that I need 20 cubic units. Okay, and then make this look like a cube. Okay, so I've got 1, 2, 3. I have 4 layers here. So 4 layers. Now, in order to make sure that I've got 20, I'm going to have to divide these into 5. So okay, perfect. So here I have my new prism. So I have 4 layers. There's 1, 2, 3, 4, but I have 1, 2, 3, 4, 5. I have 5 columns, and then here I just have, it's 1 cube. So 1 cube wide here, 4 tall, and then 5 is my length. So if I have a 4 by 5 by 1, 4 times 5 is 20, and 20 times 1 is 20. So here I have another rectangular prism that is using 20 cubic units. That's the same cubic units as this, but they look different. Okay, and so what makes these look different is that they have a different area. So when I look at this, if I wanted to look at just the area of this would be a 2 by 5. So that means that the area would be 10 10 cubes squared. If I was just looking at the flat surface down here, the length and the width. Now this one, this would be, let's see, 1, 2, 3, 4, 5, a 5 by 1. So the area would be 5. So as you can see, this here, I have, what I have in common is we still have 5. Okay, so our length has stayed the same, but it is the height and it's the width that have changed here. So only the length stayed the same. So some observations that I can make here, inferences, are that, I can change the area of these prisms, but the volume is not going to change. And the volume is not going to change because no matter how I change this, I still have 20 cubes. No matter how I arrange it, it's going to be 20 cubes no matter what, but the area could possibly be changed. So that is the end of today's math strategy video.